All right, let's pick up on page 49 where it says comparing algebraic expressions. First of all, you can denote an inequality, meaning where things aren't equal. Denote an inequality between expressions by using the greater than or less than symbols. If the expressions are the same, then they are equivalent expressions, and we use an equal sign. Okay, so let's get right into examples. It says, suppose x and y give the population of two different cities where x is greater than y. Compare the expressions and tell which of the given pair is greater. Well, if x is greater than y, then two x's are going to be greater than an x and a y. How do I know? Because I know that y is smaller than x. So the expression 2x is greater. X over y and y over x. Well, if I have, remember the x is a bigger number and the y is a smaller number. If I have a bigger number divided by a smaller number, that's going to be greater than 1. So greater than 1. And if the smaller number is divided by a bigger number, then that's going to be less than 1. So x over y is greater than y over x. Again, just read carefully and think as you go about what it is they're trying to tell you with the variables and the equations and the expressions. Suppose x and y give you the populations of two different cities where x is greater than y and y is greater than 0. It says compare the expressions and tell which of the given pair is greater. I think probably one of the easiest things to do is just assign a random number. X, let's say, is 5, and y is something that's less than that. So, we can even say 4. So we come over here, and we're going to put 5 over 5 plus 4. And that's going to be compared to 5 plus 4 over 5. Okay? All right, hopefully when you do it that way, it starts to make a little more sense and become more obvious. You can keep it just as the letters. Maybe it's obvious to you, but I'm a number person. So this is going to turn into like 5 over 9. This one turns into 9 over 5. So it says compare the expressions and tell which of the given pairs is greater. This one in that particular situation is going to be greater. Okay, I can do the same thing over here just as a test. Just pick something that x is greater than y. You can do the same numbers again if you want to and put them in here. Okay. All right, so I put everything in there the same way. 2 times 5 plus 4. 5 plus 4 is 9. Remember, think order of operations. So 2 times 9. Over here, you have 5 plus 4 squared. Remember, this is 9. And 9 squared is 81. Over here, this is only 18. So this one is definitely bigger. All right, on page 50, you have a table that's kind of handy. Again, this is the more you do it, the better you're going to get at it. But when you see phrases such as the sum of, added to, plus, more than, increased by, total, altogether, things like that, think addition. Over here, a number increased by 2, the sum of n and 2, or n plus 2, those all say the same thing algebraically. It's n plus 2. Subtraction, less than, minus, subtracted from, the difference of, take away, taken from, reduced by, all of those things indicate subtraction. The difference of a number and 2. 2 less than a number, n minus 2. Again, those are all equivalent statements that make the same expression, n minus 2. Multiplication, times, multiplied by, product of, percent of. The product of 0.6 and a number, 60% of a number, 0.6 n, where n represents the number. Again, these are all equivalent expressions said in different ways. Division, divided by, division of, quotient of, divided into, ratio of. And again, quotient of a number and 5. A number divided by 5, or n divided by 5. Those are all equivalent expressions. They all say the same thing in slightly different ways. So you're going to have to read carefully before you start to make your expression from the words. Okay. So an algebraic expression that would model the price of an item plus 6% sales tax. Price of an item plus 6% sales tax. 6% is going to be 0.06% of the price. So 0.06 times the price. So the price of an item plus the sales tax is going to give you 1.06p. Price of an item plus sales tax. Because there's no 1 written there, but we understand that that's 1p. So 1p plus 0.06p is 1.06p. The price of a car plus 8.5% sales tax. Again, it's the price of the car plus 0.085. That's how you write 8.5% sales tax. Okay. 8.5% of the price of the car is your sales tax. So price of the car plus 0.085% of the price of the car. And so the algebraic expression is P plus 0.085p. Simplifying gives you, because you can add these together, 1p plus 0.085p is 1.085p. Okay, on 7, very quickly it says to use the distributive property to show why p plus 0.06p is equal to 1.06p. Well, if I have p in both of the terms, I can take that out. Okay? And then the distributive property literally says p times this plus p times this, and that's how you wind up with p plus 0.06p, which is the same as saying 1.06p. Okay? What would 3p plus 0.06p represent? Well, it would be 3 of these. It would be maybe like you bought 3 of the same items that all had 6% sales tax or something like that on it. Okay? Okay. Some more examples. The number of gallons of a water tank that's already got 300 gallons in it after being filled at 35 gallons per minute for m minutes. All right, so the number of gallons in the tank is going to be 300, because that's how much is already in it, plus you're going to have 35 gallons a minute in there, and then you just need to know, well, how many minutes am I going to let it fill? So it's 300 plus 35 times m. I actually wrote the whole entire equation. This part is the expression that they're dealing with, but the number of gallons total would be that expression. The original price P of an item less a discount of 15%. Well, you're going to take the price minus 15% of the price, okay, to get your expression. So the price minus 15%, because that's the discount, and you're going to get 0.85p.